We've got Jeff Houston, who is the Chief Scientist at APNIC, the regional internet registry serving the Asia-Pacific region. He's closely been involved with the development of the internet for many years. Particularly within Australia, where he was responsible for the initial deployment of the internet within the Australian academic and research sector with ARNet. He's worked in the ISP sector as well as in the telco sector, and he's got extensive experience with internet services and the Internet Engineering Task Force. I'll let him explain his talk.
Thanks a lot. Good afternoon. For any of you who were around at the previous talk just a few minutes ago, which was all about software-defined radios and tiny little kits and doing it yourself, you'd realise that communications is a remarkably broad topic and covers an absolute multitude of sins, including, you know, what you can do by yourself, and at the other end of the spectrum, what you can do with a few $1 trillion. So I'm going straight over to that other section of trying to look at communications from, you know, the big side, from the industry side. And what I want to talk about is actually looking at the internet and its evolution, but tying it back into the theme of this conference, into the issue of open systems. Because this whole concept of openness, open software and open systems is relatively recent. If you go back 30, 40 years inside this industry, what you find is everything was owned. Various shops, universities, corporates were owned by vendors. The Australian National University was a UNIVAC shop. That was it. Various other universities were owned by IBM, were owned by Burroughs, were owned by folk, and everything was proprietary. You had to buy the terminals. Remember video display terminals? If you were with Digital, they were DEC ones. If you were with UNIVAC, they were Uniscopes. It was a closed world. We never see much of that anymore, apart from the iPhone, which is resurgence of the same thing. This is now a world that is dominated by openness. But how fragile is that? Will it last? So I want to talk about that from the perspective of the internet and sort of looking at this, starting not from where you are and in your comfort zone, but starting from mine. The telecommunications industry is not quite as old as computing in some ways, because if you take it back to Ada Lovelace and Byron and all the rest of that stuff, computing goes back a long, long way, whereas telecommunications realistically really started around the 1830s with the telegraph and sort of became mainstream with the telephone, first shown in the Exposition of 1876. And the industry was actually remarkable in the amount of massive innovation. Switching time is really complicated. And making a telephone network that hooked together billions of folk, reliably taking a voice stream and preserving the time components, was an amazing feat. Frequency division multiplexing, time division switching, even the artistry and technology that went into submarine cables. A phenomenal history of amazing technology. But if you're big, it doesn't mean that everything is always right. And some of the things this industry did, particularly as it related to data, were just abysmal stuff-ups of the worst order. For a while with ARNet, we actually tried to glue the network together with ISDN, the telco's dream of broadband networking. It's complete crap. It was sort of this telephone weenie's view of what computers are all about, and just had no idea. Equally ATM, this whole concept that it's because it's computers, I've got to make the cells 53 bytes long. Not 32, not 64, 53. These guys are nuts. And in fact, they were so nuts and so full of their own self-belief that all their technology was right, that oddly enough, the things that really worked in the last few years came as complete surprises. SMS was not a user tool, right? You aren't meant to type this shit into your phone. It was an accident. It was all for operators to go and sort of send each other messages of are you okay or not. And IP, I remember going down to Telecom Research Labs in 1989 saying the universities are really thinking about building this massive IP network and we'd really like your help. They look at me and go, that's old crap. We have this really good ATM network we'd like to sell you. They just didn't get it. So when you look at that industry and look at its success rate, it's mixed. And when you look at the internet, you actually find a story that in some ways exists despite the telephone companies, despite Telstra, despite AT&T's best efforts, despite a lot of these. And it's actually that transformation that happened at the same time as computers changed shape. This thing here has more computing power than the room-full machine that existed 5 doors over there that we used for undergraduate computing for the entire undergraduate faculty. This thing here. So when you couple this sort of phenomenal computing ability we now have with communications, you find a social revolution that is amazing. So amazing, we've used it all. That a lot of the original thinking, you know, which at the time was revolutionary, is now running out of puff. When you send packets around the place, packets need to know where they're going. Otherwise you get chaos. So every packet has an address going, where am I going to? And that address is basically a digital thing, you know, 1, 2, 3, 4, 5. And the real design issue with a lot of these protocols is, how big should that address be? How many bits? This university used to run DECnet Phase 3. If I remember rightly, it had a phenomenal 16 bits of address space. That would encompass 65,535 mainframe computers, which of course the ANU was never going to buy. So 16 bits seemed like a fine idea for a protocol. I don't think it could even handle this room, could it, with the amount of devices you guys are brought in. So, you know, at the time when IP came along, and the original design was around about 1982, 81 for this part of it, they actually used a 32-bit definition of an address. That was crazy talk. Complete overkill. 4 billion addresses, when at the time the world had 50,000 mainframes. This is complete nuts. But oddly enough, you know, the machine and the protocols that they were using, which were designed for worlds of a few thousand, have taken us to populations of billions, which is an astonishing engineering feat. But the problem is now we've run out. There are no more addresses, and that is pretty bad. It's like running out of telephone numbers. What do you do with the next telephone? If you can't give it a number, it's just a useless hunk of plastic. Now, the fact that we're running out should not be a surprise. It really shouldn't, because we've known about this for about 20 years. So let me take you back to a meeting of the Internet Engineering Task Force back in August 1990. PowerPoint didn't exist. Roll your own slides. And this is from Frank Zielinski, and he used a ruler. But you couldn't also you couldn't put your slides through any kind of printer. So you notice it's all hand done. But what does it say? Well, what it says was, way back then, that the internet variously had at most about 4 or 5 years to go. And it was going to run out of addresses. And the depletion dates, the first of it was March 1994, which at the time was kind of, oh my God, is that true? Because this is a long, long time ago. So we knew about this a long time ago. So what do we do? Just there on the left is Radia. So the first thing we did was actually get rid of structure. We've tried it also in telephony. You might recall in Australia that we had all these area codes. 062, 068, blah, blah, blah. So the structure was that the first few digits were an area, and the next few digits actually gave you the local exchange point, the last few digits a subscriber. So all of this structure was replicated. Now, if you're in Sydney, this is great. You'd fill up all the numbers. But what about the phone exchange for Udina data? It was given 1 million digits, but it only needed 3. Class-based addressing is really inefficient. So the first thing we did was take the class structure out of the addressing space. So there was no more this sort of, this part's network, this part's host. We actually said, well, okay, all addresses are equal, and we removed that structure. Now, interestingly, that had an immediate visible effect on the growth of the address consumption. So this is actually looking at the amount of addresses we consumed. And up the top is full, and down here is nothing. And at the time, 1985, 1990 and so on, the internet was just a research project, just bubbling along. Then all of a sudden, in 1988, the National Science Foundation of the United States said, we're going to invest $40 million and build a national research network. And we're not going to use OSI, we're going to use IP. Now one can argue that was the best 40 million bucks they ever spent. Literally, you know, guaranteed hundreds of billions of dollars of revenue over the ensuing years for America. And over the next few years, you know, Australia joined, New Zealand joined, Singapore joined, Europe joined. The network just grew and grew and grew. And as I said, by about then it was pretty obvious those curves were going to hit the top quickly. So in 1994, what we did is we changed the way we structured addresses. And almost immediately, address consumption slackened off. We thought we were so cool. This was just brilliant. Tiny stroke in the routing protocols, and we'd saved at least 4 years. And then we said, you know, we can't do this hack forever. We've got to do something better, like the Edsel forward. We've really got to get into a different kind of protocol. So we started working on a successor protocol, V6. We actually had very little idea of what it should be, other than it shouldn't be that far away from IP, and it should have a shitload of addresses, just big. We had this huge debate as to whether to have 64 bits or 128 bits or 256 bits, some folk wanted. But anyway, yes, all those kinds of debates started. That was also happening at the same time. We were young, we were naive, and we kind of thought, arrogantly, that things would happen because we said so. After all, IP had happened because we said so. We never quite understood why it was so popular. It just was. And we sort of thought, well, if that's so cool, then everything we do is going to be popular. So we sort of thought, oh, this transition stuff, we'll just work it out later because it's just going to happen. We don't have to worry about that. Now, there were other folk out there who were also working on what's a stopgap measure. And this was actually the other thing that happened way back then. And it was massive, although we didn't see it at the time. In the telephone model of networking, your handset is as dumb as dog shit. It has a dial, a speaker, and a microphone. All the smarts are inside the network. Nothing happens in the handset. In the IP model of networking, it's precisely the opposite. The network simply flicks packets. It's so dumb that it was often boasted that you can put IP over barbed wire or even IP over pigeons. And then some lunatics in Norway, because there are always lunatics in Norway, actually decided to put this to the test and implemented IP over pigeon protocol in Bergen. Good on them. But the issue about that was, and the reason why the internet was so insidiously quickly popular, was that you could build this out of really cheap shit networks because the computers fixed up all the errors. So everything is in the edge, nothing is in the middle. And this was a fine idea until NATS. Because all of a sudden these guys decided that what they would do is put an active box inside the network that actually inspected the traffic and actually allowed two end machines to share one address. Network address translation, another acronym for network address sharing. And in the document that specified that, it said, Basically, we don't think CIDE is going to give us enough time. This will give us a bit more time, a couple more years. So we thought, this is cool. We can go back to sleep because NATs are working. Christ, they worked. Unbelievable. Because when NATs became really popular, at the same time as the modem-based retail networks were coming out, you only ever got one address. And as you remember, even then, your modem, your ADSL thing, whatever it was using, actually had network address translation inside it. So all of a sudden, even though the growth of the network in the 90s was basically vertical, the address consumption was basically horizontal. This was brilliant, or so we thought. That this was just amazing. We could go on forever. Well, at least until 2050. Because that line just went out like crazy. So we thought, this is cool, don't need to worry. And of course along came the internet boom and bust of 2000, and as you see in address consumption terms, it was invisible. In the mid-2000s, everyone started deploying ADSL all over most of the planet. And even that, the pressure on the address space was sort of there, but not great. And then all of a sudden, Apple decided that this is what everyone needed. And the pressure on the address space started to really lift, as you see. And that last few years, we were getting through a massive number of addresses. And all of a sudden, 2050 was a joke. And the piggy bank, such as we had it, was looking really, really empty. And by 2011, the central pool run by the Internet Assigned Numbers Authority ran out. Now, as I said, this is kind of 20-year-old news. We knew this was going to happen. But of course everyone portrays this as the biggest surprise since, sliced bread or something, that you see from the press, oh, the net approaches address exhaustion, going, what does it mean for you, going. And then all of a sudden at the end of February 2011, 2 years ago now, there's this oh shit moment when the last of the addresses get handed out from the central pool. Bang. Now, most of you probably don't remember that, because it actually really didn't have much of an impact. Or did it? Who panicked? Who blinked? Who actually managed to go, oh my God? This is a similar kind of plot of the amount of address space being handed out in the Asia-Pac region. And you can kind of see for some years that it was tracking money. That as folk invested in new networks, pulled out new mobiles and so on, at a pretty steady pace, addresses ran out at much the same pace. And then by the start of 2010, folks started to realise the oh my God moment, that this couldn't continue forever. And that if they didn't do something in the next few months, they'd never get it. And in the last few months before the Asia-Pac region exhausted, we got through around 100 million addresses in a few weeks, just bang. So that's about as good a definition of panic as you'll ever find. Fair enough. Over in Europe and the Middle East, they ran out in September. And I would have suspected there was panic, except that the Greeks, the Portuguese and the Italians and the Irish and everyone else who went broke back around here actually changed the impetus of investment. That they might have been panicking, but they had no money to do anything about it. So, let's get more addresses. But they cost. Oh shit, we haven't got any money. So when they sort of finally ran out, the evidence of panic, you have to sort of look at a microscope, because quite frankly, it just wasn't there. And I suspect it was other factors that caused that. The North Americans, God knows what drugs they're on, but that's it. State of denial. I just do not understand why, but it's very confused. They're just slowing down. Currently, they'll run out of addresses in 2020. So I want to look a little bit deeper at this point to actually understand what's going on. What can those kind of numbers tell us? In any bureaucratic environment, and I have to admit, the folk I work for, APNIC, we're a bureaucracy. We work 9 to 5, Monday to Friday, right? And what I was looking at was how many allocations do we do per week? And bizarrely, we seem to work to rule. That we hand out 20 allocations per working day, and have done for years. That's as fast or as slow as we ever work. And you kind of wonder if I'm measuring the world or just measuring our own bureaucracy. And what I also find really strange, when we ran out, by the way, when we ran out, we still had 17 million addresses left in the pool. And the new rules are really simple. If you want addresses, you can come to us and we will give you at most 1,024 addresses for life. Whether you're big, whether you're small, no matter what. If you want addresses, that's as much as you can ever get. So a whole bunch of folk, I thought, were coming to us afterwards, were saying, I want 1,000 addresses. But oddly enough, we still only hand out 20 per day. So I really wonder what I'm measuring here, and I suspect I'm measuring the staff, and I'm not measuring the world. But you know, that's the way it's worked. This is a larger picture of looking at the entire world and where all the addresses went over time. When was the iPhone? 2006? So, at its peak, we handed out 250 million addresses. How big's the address pool? Only 4 billion. At that rate, this would have lasted only 16 years anyway. And of course, when we ran out and then Wright ran out, so last year we only handed out globally 114 million addresses. Where'd they go? China, 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 till we ran out. The US was sort of going and is still there, but there are some very interesting economies there one way or another. Colombia, Romania. As you kind of see, there are folk all over the place. Brazil figures very, very heavily. These days addresses go where there are population one way or another, and it does vary. But the network and the industry change. ARNet started out as a bunch of universities. And then it started servicing a bunch of what we called ISPs, which were small-scale entrepreneurs, and I'm sure a lot of you knew them too, that were sort of doing the ISP thing. And there's this mythology in the industry that it's still highly competitive, there are still ISPs, and the industry is highly diverse and remarkably good, you know, it's efficient. What crap. At the carriage level, the telcos own the lot. They own the lot. And you can see from where the addresses went. In 2011, NTT managed to get 8.4 million of them. Then China Mobile. The Indonesian telecommunications network that does mobiles, KDDI and so on. That's basically a list of major telcos all around the planet. There's no more small-scale ISPs anymore. This industry has basically agglomerated like crazy, and these days it's all about what the big folk are doing. But you know, small folk still exist, data centres still exist, the industry is still diverse, and let's say that you've all decided that it's time to build a data centre, the LCA Cooperative Data Centre. And of course you haven't got any addresses right now and you want to build a data centre, it's in com, so what are your choices? What are you going to do? Well, not too many choices. You can come to APNIC and you can ask for an address allocation in V4. Fine. We're going to give you at most 1,024 addresses, which for a data centre just works. Which reminds me, when you want to set up a secure website, HTTPS, can you do it behind a NAT? No. Can you even address share in HTTPS?
Yes.
Just. Almost. It's a pain. For the industry, this is poisonous news. I want my address, it's my address, I'm not going to share it with anyone. So folk who do secure websites largely want the address. So that's what's going on with these addresses. They're actually being taken up on the supply side, running basically into data centres. But for anyone doing an ISP, anything like that, 1,024 addresses is not a lot. It's really hard. So this is only marginally useful. So what about V6? God. It's been around now for many, many years. Many, many years. And you'd think by now that we would have done something. And we have. Every single Microsoft machine out there from Windows 7 or Vista or whatever it was onwards has V6 in and turned on. And all of the Microsoft apps try to use it. Every single Mac these days has it in and on. Most Linux distributions have it in and on. Even these things have it in and turned on. So considering how quickly we recycle technology, most of the stuff out there talks 6. And if I look at the big networks, I want to move packets around the world, most of them handle 6 as well. So that's an amazing achievement. And we thought, well, this would be really cool. Let's measure how much 6 is out there. What we did was we wanted to actually get everybody, or as many people as possible, to use 6 by accident. You know when you have an ad, you can put code in it? So we coded up inside Flash a test for V6. And we went to a number of the ad folk and said, we want a few million impressions. And currently we do about 1 million impressions a day testing most of the planet. So when you see an ad that says measuring V6, for God's sake don't click it, because I have to pay for the click. But as long as you don't click, I get the measurement for free. It makes no difference to you because it's all in the background, and I can actually tell how much of the world is running 6. That scale there from 0 to 0.8 is in fractions of a percent, not in entire fractions. So at the moment, after a bit of a Christmas blip, because you all went home and home seems to be better than work, there's very little 6 out there. Isn't that bizarre? That most of the world is capable of running 6, but doesn't. Why not? Who runs dual stack? How many have met the white screen of death? Thank you. How many have met path MTU issues? Thank you. How many have had an overall pleasant experience? I haven't. Because sometimes these machines are so crap at dual stack that it's easier and faster to turn off 6. If you're running Windows, what Windows does is if V6 is up and running, it always tries to make a connection in 6. But what if it's broken? What if I can't get there? How long does Windows take to flick back to 4? 19 seconds. If I'm running Linux, on the other hand, an unadorned version of Linux using the standard defaults that come out of Debian, how long does it take to flick back to V4 if the V6 path doesn't work? 3 minutes and 9 seconds. Is any user that patient? I hear Google talk about the $1 million millisecond. And at the same time, even this Mac, when it was doing that, because they changed it, was 75 seconds. So turning on dual stack, if the 6 part of it was slightly flaky, caused the user experience from hell. And no ISP was willing to do that. And all of these networks said, oh no, not going to touch it. Telstra's entire mobile network, 3G, 4 only. The LTE network so far still, 4 only. There are very few ISPs in Australia that actually give you 6 by default. Internode, 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 and Internode. That's why this number's so shit. None of the providers of the last mile access are willing to take the punt. Even though all the machines have it, even though we're all quite capable of doing it, the business dynamics and the helpline call costs and so on say it's not going to work. So yes, you can go and set it yourself in IPv6, but you can only see 0.6% of the internet, or 0.6% of the internet can see you, and that's not a lot of internet. So that's not going to work either. You're in Australia, you can't go to anywhere else, you've got to go to APNIC, you're only going to get 1,000 addresses. What if you want more? Well, you've got to look at the person beside you and see if they're willing to sell. Now, when you buy and sell addresses, normally you need a title. like buying and selling a car or a house or anything else, because otherwise I pay you money, you give me integers, so what, right? It'd be nice to know that you no longer had access to those addresses, and I did. So these sales are actually registered in the registry. So I went back and looked at the number of sales per month. And that's a scale of 5, 10, 15, 20. God, it's not a lot. 20 per month on average. So whatever's going on, folk aren't buying and selling. Here's the amount of address space that's being sort of moved around. And these are in 0.2 of a million addresses, 0.4, 0.5, 0.6. That's not a market. That's just a bunch of folk playing around. So that's not going to work. We don't care anymore. Because what we care about is actually now carrier grade NATs. I'm on Telstra. And if I cared to have a look at the IP address that I'm currently running here, I will find it's 10.0.1. something or other. So's yours, no matter what carrier you're on. You might have a data modem, and some folk actually give you a real address, but most folk don't. Almost everyone now in the mobile part of the world uses carrier grade NATs. And increasingly now, this is actually happening in the wired part of the world as well. So instead of just one box at your edge, now address sharing happens in two places, because a second box up there is also doing address sharing. Why? Why did the internet happen? Because we were cheap bastards. We could do everything the telco was doing with crappier service for about 1/10 of the price. You didn't care because your computer made up the difference. I lost a packet, send it again, right? Paths go down, well, routing just heals it. We were cheap. So why are CGNs, carrier grade NAT, so attractive? Well, because they're shit cheap. The cost of putting this in, the fully amortised cost of putting in carrier grades NATs, is less than $40 per user per year, and it keeps on coming down. V6, on the other hand, is a lot more expensive to actually put up and set up and construct because of the issues around reliability and service. I can do it without you, whereas the V6, it's only worth me doing it if all of you do it. We have to do a sort of mutual contract. Carrier grade NATs, I can act independently. I don't need to coordinate with anyone. And theoretically, all the applications still work. We'll get back to that. The carrier infrastructure is unaltered. So all of those really cheap, crappy BRAS units that Telstra bought to fuel their ADSL network that run V4 only because they don't have enough memory to run V6, still work. Your investment's preserved. So the marginal cost is low, investments are preserved. It's cheap, just works. However, HTTP works.
Quick question, Jeff. What is carrier grade NAT versus NAT that you don't understand? What's exactly different about it, if anything?
It's not yours. And it costs a lot more. It's more expensive. Same software, it's the same shit software made from Taiwan. No change. The thing about this is HTTP will work, but now the port space in those connections are being shared amongst multiple users. So I don't have 65,535 ports to play around with. If the network provider out there is sharing me amongst 6,000 other users, you know, and it's crap TV and it's 6 o'clock in the evening or 8 o'clock in the evening, how many ports do I have? About 10. So all of a sudden, parallelism, which these days is simply part and parcel of the way we get speed, doesn't work the same way. UDP will kind of work, but not the way you think. Because if I want to share the ports amongst more users, UDP binding times shut down. If you're not using UDP or TCP, you're not using the net, because nothing else works. You're writing applications. You love writing applications. How do you write an application that works inside this environment? Because all of a sudden, things are different. And everything has to be symmetric, because all the stuff has to go through the one NAT. So this is not good news. And in fact, it gets slightly worse, because if you look at the standard model of the way carriage systems used to work, The telco was an integrated unit where they made all the money from the service and subsidised all the rest of the infrastructure from charging folk for voice calls. But these days, the internet isn't like that. Google has all the money, Telstra doesn't. And Google doesn't pay Telstra. We pay Telstra, and we pay it just for the transport. So the model and the underlying economics are now vastly different. The money from services doesn't translate into money for infrastructure. And this causes huge structural problems in the industry. Because you and I are paying the access provider. The service provider is simply running straight over the top, independently, and they make lots of money. They do very, very well out of this. But a carrier-grade NAT is a bit like a toll box. Because all of a sudden, with a carrier-grade NAT, the access provider has visibility to the traffic. All of a sudden, the rationing model changes in networking, and the carriage provider gets a look in. There's a few examples I'll just go through, and I'll only take a few seconds. Why this debate about network neutrality? Because it's a real problem. Because now, at the moment, while the content folk are making lots of money, the carriage folk are feeling they're being left out of the picture. Once we've exhausted V4 addresses, there's no such thing as end-to-end anymore. All of a sudden, your traffic is pulled apart, and sometimes the content is changed. This is from earlier this month, where Free, a rather large ISP in France, has been doing ad substitution. Because they make money from their ads, they don't make any money from carrying other people's ads. And because they have visibility on the traffic, they can. Over in Korea, 12 months ago, Samsung launched a smart TV. Korea Telecom said, no, that's our network. We want a cut of the ads. Samsung said no. Korea Telecom said, well, you can't use our network then, and blocked their network for those TVs because they could. When you give these guys visibility to traffic, you're giving them a lot more than you think. Because all of a sudden, the things that made openness work are under threat. Agility, minimalism, and efficiency are all changing. Because these days, this is not an open platform. It's made by Apple, controlled by Apple. The apps are blessed by Apple. There are very few things that I could do without Apple knowing. Proprietary systems predominate our world. They are phenomenally inflexible. If you're writing an app that will work anywhere on the internet, complexity is now a real issue, and costs are changing. What protocols can you use? Well, if you look at etc. protocols, you'll find a whole load of bullshit. There's only two that matter these days, just TCP and UDP. Nothing else works. Not even ICMP, unfortunately. And what about TCP and UDP? If I send you a packet, what's the only port number where I can be absolutely assured that the packet hasn't been buggered around within the network?
80.
No, 80's proxied like crazy. 25, no. 21, no. I reckon the only one is HTTPS port 443. Oh, bugger it, I'll take that off the slide as well then. There's nothing left. Because that was your only hope for end-to-end clarity, and if that one's gone, this is shit. Because all of a sudden, openness doesn't exist anymore. This whole idea of permissionless network is over. That if the network is so ridden with middleware, and so ridden with folk whose economic incentive is to restrict the edge because they want their money back, and quite frankly, the internet is a pretty crap place. But if the internet dies, what happens to all the open system innovation that goes along with it? How open is this platform? If that's the world we're looking at, then The Economist of a couple of weeks ago is right. What we've really done is shut down the last 10 years of fascinating, marvellous, mind-boggling innovation and replaced it with crap. It's time to think about this and choose very carefully. We're just at the forefront of a world that's totally revolutionary. We can make a world with abundant comms and computing. It's now commodity. I can buy disk space like crazy. I can buy computation like crazy and rent it by the second. This is a world that when I started working in this environment 30 odd years ago, never dreamt would be possible. That I can hook up a server somewhere else on the planet, run it up, set up terabytes of space, conduct an experiment, shut it down in a week for cents. What an amazing world. Or you could have where we're currently going. Because where we're currently going is nothing like that. It's a world that's fully corporatised, that has massive barriers to you and I doing anything useful. I'd like to say that we understand this and are going in the right direction. But regulation finished with this industry years ago. It's just market forces. And I, probably like you, have no idea where that's going. I'd like to think that we're clever folk, that we understand about the world and we understand about our environment. And we'd never, ever, ever chop down the last tree. Or would we? Done it before, do it again. Thank you.
So we have 5 minutes for questions, if anyone has questions.
I'm just going to say, your graph of the uptake of IPv6 was showing preference. Do you have any idea of actual reachability if you only gave them a quad A record?
Yes, I have a second graph of capability, which is I give you a URL that is only 6, it's not dual stacked, and if you can possibly go there, you will. Instead of 0.6%, it's 4%. And you think, oh, this is really cool. It's more than I thought. Most of that 4% is actually 6 to 4, which is this Windows bullshit about tunnelling. And the problem with this Windows bullshit about tunnelling is that the failure rate of connections is up around 15 to 20%. So 15 to 20% of the folk who sort of launch this 6 to 4 connection don't get an answer. And we thought, this is really curious. Why the hell is that happening? Because most of you run some kind of crap firewall with your modem. And your crap firewall thinks that protocol 41, like every other protocol other than 6 and 17, is evil. So the return packet, protocol 41, gets blocked. So yes, there is a higher number, but the story's still crap.
So are you saying that we should give up on IPv6?
No. But I don't understand how we're going to get there. But the least I can say is if you're designing apps, for Christ's sake, use a UI. Use a platform underneath it that gives you dual stack. That actually makes some sensible use of parallelism. That instead of adopting the very early approaches we did here, where you try v6, wait for 3 minutes and then fail over, try them both at the same time. Actually do connection attempts when you're doing network programming that exploit the idea that I've actually got independent stacks and I can probe independently. Make the experience for the user positive and we might have a glimmer of hope, a glimmer. But if you do nothing on the supply side, the applications and services, the world is going to blithely go into carrier grade NAT hell and we're never going to come out. So the least you can do is at least give it a hand.
Too late.
You know, I start out on Monday feeling pretty optimistic most weeks. As you can tell by Wednesday, it's looking pretty shit. And you don't want to hear Friday's talk.
You see this stuff from a lot of perspectives, which is great. And from a market forces perspective, do you see that there's the possibility for another boutique ISP to launch in Australia and provide V6 as one of its main offerings and remain economically stable?
I'm sure that at the technical level, most folk would actually love to run V6 inside the ISPs. I know working inside Telstra, we really wanted to do it because it's boring doing anything else. You know, V6 was a new set of challenges. And quite frankly, when we're mucking around inside Telstra's internet product, we had a fun old time putting it up. So from the sort of interior side, everyone would love to do it. But as soon as you hit the product managers, the shit really does hit the fan. Because when you start doing dual stack provisioning, there are issues. Look at Telstra's own network. The 3G network is stuck in V4. They're never going to change that. They had the opportunity with their 4G network to run dual protocol. But as you might have noticed with these kinds of things, when you roam from a 4G cell to a 3G cell, your phone doesn't stop. Everything keeps on working, yes? But what if the V4, the LTE network was 6 and 4, and the 3G network's still 4 only? What happens to all your stuff? Because one thing you can't do with a live connection is fail over from one protocol to the other. So all of those business issues impact the problem. And quite frankly, though Internode did a fantastic job, they failed to persuade the large-scale folk to actually do something. And that's the same the world over. It's not just an Australian condition. I frankly would love to see how to break out of this, but you know, it's a tough problem.
So one of the best arguments I've heard about actually making carrier-grade network in practice is that you've got the Akamai's, etc. of the world now doing V6 on their CDNs, thus allowing somewhat of an end run. And if CDN traffic is on the order of half of all traffic for an ISP, it becomes a very easy way to enhance the scalability, and the CDN, the traffic going to those CDNs is often more user visible.
You know, it'd be great if vendors and operators and data centre folk took all this stuff seriously. You go to any vendor if you're building a data centre saying, I want dual stack equipment, load balancers, the lot, running both 6 and 4. A, they will laugh at you. B, they will inquire as to your bank balance. And C, they'll tell you haven't got enough money. And even if you did, they don't build that stuff anyway. It's all experimental. There's a very complex supply chain into our industry now, and most of it's wedged in 4. And it's really hard to break that nexus. And like I said, it's Wednesday. Things are looking shittier than it were on Monday.
Sorry, we've run out of time for further questions. I'm sure Jeff would be willing to take questions afterwards. So let's thank Jeff again, and from Linux Australia.